Can you hear me now?
Yes, of
You got
course.
me? Okay,
Tim,
good.
I will present Tim. Tim is the sports science director of Football Club Chelsea. I met him a few years ago with
Yes,
Bruno Ellis and
that's right.
Lotti in London. Tim is a colleague, is a psychophysiologist, and
That's correct.
please give us your precious information and presentation. Thank you.
Well, thank you very much for having me. So I started off life as a psychologist, but it was really through working with our mentor, Bruno de Michaelis, that I began to be introduced into the world of sports science. And I've ended up as head of sports science at Chelsea Football Club. I've been doing that job for the last 5 years. So what I'll be doing is talking a little bit about just the philosophy that we use to manage the physical load of the players. And I'd just like to invite anybody, if you would like to send me a message on the chat, I've got the chat open while I'm talking. And if anybody would like to send a message, please ask a question as we go. I think that can just make it more interesting. So what I will do now is share my screen. Will you just tell me when you can see that?
Yes.
You got it?
Yes. Yes.
Okay. All right. So we call our sports science system at Chelsea Blue Sprint. But something interesting about it is that this is not unique to Chelsea. The principles are being applied at a club playing in the Turkish league called Trabzonspor. And my son, Malcolm, is head of sports science there. And they've actually achieved a remarkable reduction in the injury rate while he's been there. And that's imposing with the Turkish Super Cup that they won just 2 days ago. So, you know, we're talking about a project that is taking place in a couple of top clubs. So just to introduce you to the principles, and then I'll talk you through them one by one. But like I said, please send a message if you'd like me to clarify anything. The first principle that I'm going to be discussing is the idea of work rate, that we have an objective measurement of how hard a player is working at any given moment in time. The second principle is that we use an idea called EMM, or equivalent match minute. And the reason why we do this is that we have a way of measuring load that makes everything equivalent to how hard somebody would be working in a match. And it just means that we've got a common form of, we've got a common currency when it comes to understanding how hard somebody has worked. The third principle that we use is that fitness is multidimensional, not essential. So we're really saying that we don't believe that you can express fitness with a single number. We think you have to accept that there are many dimensions to fitness. The fourth principle is that we infer physical condition from knowing what the player has actually done. So we don't try to measure something about what quality the player has. We're not looking at muscle temperature or measuring other sort of essential characteristics. We're not trying to capture the player's condition with some sort of instantaneous measurement. We're inferring how he is because we know exactly what he's done. The fifth concept is that we have a very rigorous target setting program that we know exactly what we want every player to do in a given week. We know exactly what we expect from every player in a match, in every different kind of training session. We can tell you in complete detail what we expect from every player. And the sixth concept is that of context, that we undertake that all the information we present to fitness coaches and to the technical coaches, we undertake that all of that is delivered in context. And the reason why is because as soon as you receive a table of numbers, if you've not had context given to you, you will begin to impose your own context. So what I'll do is I'll just start and I'll work my way through these ideas. So the first idea is that of work rate. And work rate is a measure of how hard any player is working at any moment in time. And it happens roughly on a scale of 1 to about 350. So, you know, or 0 to 350, 0 is when the player is standing still. 350 is when he's at the extreme of his anaerobic potential. And a way of understanding work rate is that work rate correlates roughly with heart rate. The reason why we don't use heart rate is because heart rate is not a universal measurement. It varies from person to person, and it even varies in one person from day to day. So we couldn't say that just because one player's heart rate is 180 and the other player's heart rate is 160, that they're working at different intensities. Whereas when we measure work rate, it's a universal measurement, it's an objective measurement, and we know that if one player has a higher work rate than the other, it's because that player is working harder. So what we do to calculate a work rate is we have an algorithm that calculates the equivalence between degree, duration, and intervals of speeds and accelerations. So basically what we've got to be able to calculate is we've got to know the difference between one player doing a low speed run for 30 seconds and another player doing a high intensity acceleration for 5 seconds. And we've got to turn those both into a calculation of how hard that player is working. And what we end up with is this line that shows how hard somebody is working at any moment in time. This particular visual that you're looking at is an average of the entire squad. And here we are measuring ourselves to an opponent, and you can see that there are particular peaks where you can see the blue peeping above the yellow, and that's a sign that that our team was working harder than the opponent at that particular moment in time. So that's the work rate calculation. Now I can't actually see the comments at the moment. I'm not seeing any questions, so I'm just going to carry on with the presentation. So that's the first idea. The second idea is the concept of EMM, or equivalent match minutes. And basically the concept here is that EMM is a measure of load. And what we expect is that in a typical Premier League game, when a player plays 90 minutes, we expect that they will score 90 EMM. And what that means, so the first idea, and what I have here is I have a list of EMM for a set of players who've played in a particular match. This particular player played all 90 minutes, but he only scored 76 EMM. This player, on the other hand, played all 90 minutes and he scored 90 EMM. So what we can say is that if we had taken this player off after 76 minutes, he would have done exactly the same amount of work as this player has done after 90 minutes. And this player here has done 75 minutes. This player was a substitute. He's done the equivalent of 29 minutes, of 29 match minutes. And the reason why this is useful is because we know that some players have worked harder than others during a match, but it also means that we know in training, this is a training session. And here, for example, we can say that in this training session, this player did the equivalent of 44 match minutes. So it's as if he had gone and played a Premier League game and had played 44 minutes of a Premier League game. On the other hand, this player in this training session, he's done the equivalent of 36 minutes of a Premier League game. So that's our second principle, equivalent match minutes. The third principle for us, let me just find where I am. The third principle for us is that, sorry, got a bit lost here, is that fitness is multidimensional. Now, what I mean by that is you cannot just say that somebody is fit or unfit. There are many different categories of fitness. So the categories that we use are, first of all, work rate, which is a measure of aerobic work. Then we use speed and distance, we use acceleration, and we use deceleration. And within each of those four main categories, there's subcategories. For example, in speed, there's not just total distance, there's speed above 18 kilometers an hour, 21, 24, 27, and 30. And what that means is that we are interested in looking at every single dimension. We don't just want to say, yes, the player's fit, or no, the player's not fit. We just don't want to say, a lot of times, for example, we find that people just use total distance as a measure of how hard a player has worked. But because of our ability to actually manipulate data efficiently, it means that we can actually engage with every single important category. And my challenge to anyone is, tell me which one of these categories don't matter. Because you need to talk about work rate, you need to talk about speed, you need to talk about acceleration and deceleration. They're all completely different things. So you can't cut any of them out. And secondly, 18 kilometers an hour is completely different from 24 kilometers an hour, which is completely different from 30 kilometers an hour. So this is why we're interested in all of the dimensions of fitness. This is quite important to us. And what that means is that a player can be fit, overloaded, or underloaded in one category, but not in another. So sometimes we may find that a player is overloaded for aerobic intensity, but he's underloaded for speed, for example. So that's the third of our principles, is that fitness is multidimensional, not essential. What I mean by essential is that it has an essence, it has just one thing. We're saying it has many different dimensions. The fourth principle is that we infer physical condition. Our judgment of how fit a player is comes from understanding what it is that he's actually done. And what I have here for this particular player is I have a list of 8 weeks of work. And for each one of those 8 weeks, I know whether he's been above or below the targets that I've set for him. So the green colors are for below target, the blue color is within target, and the red color is for above target. And I can see that right now in this week, for example, this player is showing a lot of blue. In the week before this, he's also showing a lot of blue. I know that he's got a slight deficit in his aerobic work. And this is what I use to infer how fit the player is, not by giving him a fitness test. And then what I end up with, so you can see here, I've highlighted one particular player. And what I have here is I have a snapshot. I've just chosen 4 players here, but I can look at all the players in the squad on a single page. And I can tell, for example, that this player here, because he's showing a lot of blue in the acute category, that means he's done pretty much what I wanted him to do in the last week. He's showing a lot of blue in the chronic category. That's showing he's done pretty much what I wanted him to do in the last month. That means that I can say with a high degree of confidence that that player is fit. Not because I've given him a fitness test, but because I know what he's done. Then the fifth concept is that of targets. Now, part of the concept of targets is that I understand that fitness is multidimensional. But what I end up with is I end up with a very detailed set of targets for every single player. And here I have my players. And I'll talk about this, this table on the right for starters. And you can see for every single player in the squad, I have a specific target for every category of fitness. So it means that I'm dealing with 20 categories, 20 players. I've got 400 targets that I've set, and I've gone through those painstakingly. Every single player, I've looked at every single target, and I'm updating those because I need to be confident that every single player is getting exactly what he needs. And it means that when I go back to this chart over here, and I'm saying that this player is either within or outside his targets, I'm assessing him against an extremely rigorously and painstakingly assembled set of targets for every single fitness metric. And that's why, for example, this player is above target in his his deceleration of 3 meters per second. He is below target in his work rate above 230 EMM. Whereas for his speed distance of total distance, 21, 24, 27, I know that he is within range. So that's the fifth principle of our philosophy, is that we set detailed targets. Means that every single time we're looking at a player, we're looking at him in relation to those targets. And our sixth philosophy, our sixth principle, is that of context. And what I mean by that, and the reason why I started doing this, is because I noticed that unless you force people to look at the right context, they will pick the wrong context. And generally, the first thing that happens when you give people a table of numbers is that they start comparing one player to another. But that's not the useful context. The useful context is when you are comparing any given player to his target for that session or for that week. So what I have on the right-hand side, this table, is I have players, and the blue and the green once again show where the player has been below his targets for a match. The blue shows when he has met his targets for the match, and the red has shown when he has exceeded his targets for the match. And obviously this player, you can see that his total EMM is 12, which suggests that he's a substitute, and you can see that he has exceeded his normal match intensity, which is what you would expect. Whereas this player here is an EMM of 88. He's played most of the match, and while he's had a normal work rate, he's had a slightly lower than normal speed. So that means that I'm looking, the context that I'm being forced into is comparing the player to himself rather than to another player. This here is an analysis of the entire squad's output. And what I'm doing here is the top table is our team. The bottom table is our opponent. And I can see that in this match, for example, because our team's numbers are all in blue, I can tell that it was an entirely within expectation performance from our team. But if I look at the opposition team, I can see that they were substantially below our own averages for speed, acceleration, and deceleration. And what that means is, because I'm always making reference to context, it means that I can very quickly draw conclusions from what is otherwise an extremely complex amount of data. So, you know, just to recap, those are our principles: the idea of work rate, that you can measure how hard a player is working at any moment in time; the concept of EMM, that we can calculate a total load; we use multiple dimensions; we measure what people have done; we base our judgments of fitness based on what they've done; we set targets, and we use context. So, you know, that's a whistle stop through some of the principles that we use to manage the physical load of players.
Thank you so much, Tim, for your amazing presentation. Very interesting. So just one thing, you stay with us until the end, or you have to go?
Unfortunately, I'm going to have to go fairly soon.
Okay, just a very...
I can rejoin possibly. Should I do that rather?
Oh, we have Davide Ancelotti with his relation, and after we have the question. Okay.
Okay, so I will rejoin if I can.